Last thing that we're going to talk about in this class is continuing on with the non-parametric tests, but suppose we are comparing independent samples. So the Wilcoxon rank sum test can be used for two independent samples. Your book discusses the Wilcoxon rank sum test, which is different than the Wilcoxon signed rank test. The Wilcoxon signed rank test is the one we did with matched pairs or one sample. The Wilcoxon rank sum test is for two independent samples. Minitab doesn't do it, so we're not going to be using it except when you read your book. But Minitab does the Mann-Whitney U test for two independent samples, and they are equivalent tests which would give the same results. They're different tests. They're not equal tests. They're equivalent tests, and they both would give the same results. Non-parametric tests use the rank of sample data from the two independent populations. It's used to test the null hypothesis that the two independent samples come from populations with equal medians. Remember, it's medians now in Chapter 13 with non-parametric, not means. It's a common mistake when students are trying to do the cumulative final and they're dealing with both parametric and non-parametric tests. And the alternative hypothesis is the claim that the two populations have different medians. Are the two samples need to be independent and randomly selected. Each sample has to have at least 10 values, and there's no other requirements other than those two. No distribution requirements. The Minitab procedure, Minitab doesn't do Wilcoxon rank sum, but the Mann-Whitney is equivalent, and Minitab does the Mann-Whitney U test. You enter the two sets into columns 1 and column 2. You do not need to subtract, so people with Minitab Express, the Mac people, don't have have to do any extra work with these problems. You select stat, select non-parametric, select not Mann-Whitney. You enter in sample 1 as first sample, enter in column 2 as second sample, then select your appropriate hypothesis. You think median 1 is different than median 2, then you enter in not equal to. Think median 1 is less than median 2, then you enter in less than, or median 1 is greater than median 2, then you enter in the alternative being greater than. Click OK, and it'll give you the results. Here's it's example 1 in this section in 13.4 in your textbook, and it's the pulse rates of men versus women. So enter in the 12 values of male BMIs into C1, and enter in the 11 values of the female BMIs into C2. We are just testing our null hypothesis is the two medians are equal to each other, and our alternative hypothesis is the two medians are not equal to each other. Click OK. And you get that the median pulse rate for men was 68, and for female it was 78. Our test statistic is now a W. It's a different distribution, 123.5. It does give us a confidence interval also of -20 to 4.01. Now recall, way back in Chapter 8, when we first looked at testing hypotheses using confidence intervals, if 0 is in the interval, we do not reject the null hypothesis. We fail to reject the null hypothesis. Also, the p-value concurs with that result, saying we get a p-value of 0.2184, which is greater than our significance level of 0.05. And again, the result is fail to reject the null hypothesis. So I just want to make you remember that with confidence intervals, you fail to reject the null hypothesis if 0 is within that interval, and 0 is between -20 and +4. And using the p-value approach, if the p-value is greater than 0.05, again, we fail to reject the null hypothesis. So in this case, there is not enough evidence to suggest there is a difference between the pulse rates of males and females. We have 3 or more independent samples. Then remember the ANOVA test was the parametric version, and the non-parametric version is known as the Kruskal-Wallis test. It's also called the H test, and you're going to see our test statistic is an H. It's a non-parametric test that uses the rank of sample data from 3 or more independent populations. It's used to test the null hypothesis that all of the medians are equal versus, not that they're all different, but that at least one of the medians is different from the others. That's all this test tells us. If you found that you rejected the null hypothesis and that at least one of the medians was different, this test does not tell you which one is different. You would have to do post hoc comparison tests to figure out which ones were different. That's a concept we will cover in a more advanced statistics class, not in this class. The requirements are that you have to have at least 3 independent samples. All the samples need to be randomly selected, and each sample has to have at least 5 observations, and other than that, there are no distribution requirements. Is a little different than what we did with ANOVA. In this case, we're going to enter all of our values into one column, and then all of our identifiers into another column next to it. We're going to select stat, non-parametrics, Kruskal-Wallis. You're going to enter in those values into the response box and the identifiers into the factors box, and then click OK. So for example, I have this example comes from page 589 in your textbook. You're going to enter in all 18 values in C1. The next two, all of the values that came from the smokers, in column 2, you're going to put ones next to all those values. Then to all the values that came from the non-smokers exposed, you're going to enter in 2s into the column 2. And for all the non-smokers not exposed values, you're going to enter in 3s into column 2. Then you're going to enter and select C1 for responses and select C2 for your factors, and you click OK. Is H is equal to 8.11. My p-value is 0.017, which is less than 0.05. So we reject the null hypothesis. Now, it did not tell us which one of those 3 are different. It just tells us that there was enough evidence to say at least one of those medians is different from the others. They may all 3 be different from each other, but at least one is different. And that's the end of chapter 3, and that's also the end of all the material we're going to cover in this class. You need to go to my math lab and do the homework assignments. Then watch the lecture recording for Minitab Lab 13. Download the lab, complete the lab, and then upload the appropriate document into the portal under coursework. And be sure and contact me if you have any questions about the material, or about the homework, or about the Minitab lab. I've enjoyed teaching the class. After you finish chapter 13, it's time to start studying for a comprehensive, cumulative final exam, which can replace your lowest test grade if it is better. And you can read more about it on the syllabus, about that fact on the syllabus, or just contact me and I'll explain it to you one-on-one.